Okay, so this is section 2-7, number 18. So the first one asks for the average rate of change on the interval from 20 to 60. So we know the formula for this is f of 60 minus f of 20 all over 60 minus 20. So if we look at the graph, looking at f of 60, it's around 700, and f of 20 is around 300. So I'm going to write that down as f of 60 is 700 minus f of 20 is 300 all over 40, which simplifies to be 400 over 40, which simplifies to be 10. Okay, part B asks to identify an interval with the average rate of change of f is 0. So what we're going to do is we're going to look at the graph, and wherever the points are equal, that would be 0. So if we look, the point of 0 and the point of 10 and 50 are the same. And so if you subtracted both of those would equal 0. So on the interval 10 to 50, let me write that down. That would be 1. Okay, now for letter C, on which interval gives a larger average rate of change, we have 40, 60, and 40, 70. So let's do this one first. So we have f of 60, which we already found, as 700, and f of 40 minus f of 40, which happens to be 200, all over 20. And then f of 70 is 900 minus 200 all over 30. So this happens to be 25 and 23.5. So we can see that f of 40 to 60 has a larger average rate of change. And then lastly, we're going to look at letter D. It asks to compare f of 40 minus f of 10 over 40 minus 10, and what does it represent? So the average rate of change represents the value. So the value represents the slope of the line segment from the interval. So for this one, it'd be from 10, f of 10 to 40, f of 40. So let's actually do it. So f of 40 minus f of 10 over 40 minus 10 turns out to be 200 minus 400 all over 30, which equals negative 20 thirds, which is also negative 6 2/3.